How's it, grade 11s? Today we're going on to applications of radian measure, and the one that we're going to be doing is arc length. So I am working from this page over here, which is page 87. Okay. So first of all, here is your formula for arc length. So S stands for the arc length. Now your arc length is this little bit over here that I've highlighted. Okay. And obviously you need to know the angle between your two arms here, your radii, and then the length of the radii. So S, or arc length, is equal to R times theta, the radius times your angle between the two. Now remember that this angle must be in radians. Okay. Now from this, obviously we can get two other formulas. We can work out what R is, which would be equal to S over theta, and then theta, which will be equal to S over R. Okay, now the one in the yellow is given to you on a formula sheet. These other two aren't, but I mean you can just derive them from this one over here. Now another thing, grade 11s, they're going to be talking about like a minor arc or a major arc. Just remember the minor arc is the smaller one. So this is the minor arc, and then obviously the bigger one would be the major arc. Okay. So minor just being the smaller, the major being the bigger. All right. So let's have a look at some examples here from your book. Okay, so example 1 is saying an arc PQ of circle center O. So what I'm going to do is I'm just going to draw a circle, and then just from that just draw our arc, which they said was PQ. Center O with radius R centimeters, and subtends an angle of theta radians at O. The length of arc PQ, this little length here, is S centimeters. Calculate the unknown in each case. So question, this is example 1. Question A. So they've told us here that R is equal to 4,5. Theta is equal to 4,5. And the thing that we're missing here is S. So we need to calculate what S is equal to. Okay. So just coming back to our formulas here, this is the formula I'm going to be using because I need to work out what S is. So S is equal to R theta. Simply just plug in your values here. So you get S is equal to R is 4.5 multiplied by theta is 4.5. And if you put that on a calculator, you will get 2,025 centimeters. Okay. Question B is still dealing with this circle over here. So question B, now they're asking, they're saying that S is equal to 1.5. Theta is equal to 5 pi by 12. And the thing that we're missing here is the R. So we need to work out what R is. So again, just coming back to your formulas that you just learned, R is equal to S over theta. So R equals S over theta. Simply plug in your values. So we get 1.5 over 5 pi by 12, and then you can plug that in your calculator and you will get 1,146 centimeters. Okay. Example C, they've given us that S is equal to 12, R is equal to 7.5. So the thing that we're missing is the angle theta. Okay, again, from your formulas, theta is equal to S over R. So theta equals S over R. Plug in your values, so S is 12, over R is 7.5. Plug it in your calculator and you get 1,6 radians. All right. Okay, so let's go on to example 2 now. Example 2, they're saying a circle of diameter 6. So I just want to draw in a picture here. So a circle with a diameter of 6. So this whole length here is 6 centimeters. Has a minor arc AB. So we can call that one A and B. Now remember, they're talking about the minor arc, not the major arc. So your minor arc is the smaller one over here, from A to B. Okay, and that subtends a central angle of 2 radians. Determine the length of the minor arc, AB, and hence the length of the major arc. So what I'm going to do first is find out this highlighted bit, AB. But in order to do that, I need my radius. So what they've given us here is the diameter. So the radius would be equal to half that diameter. So R is equal to 6 over 2. So R is equal to 3 centimeters. Okay. So again, just from your formula, we know that S is equal to R theta. So SAB would be equal to our radius now is 3. And our angle is 2. So we get an arc length of 6. Okay. 6 centimeters. And just remember that this is the minor arc. Okay, so we've answered the first bit of the question, which is find the minor arc. Now what we need to do is we need to find the major arc, the length of the major arc, which is the longer bit. It's this bit over here. Okay, so that's the bit I need to find now. So in order to do that, what I need to do is, if we look at the circumference of a full circle, we know that the circumference of a full circle would be 2 pi r. Okay, so just remember that the circumference is equal to 2 pi r. And that would be, say, for example, from A to A. And now what we want to do is we want to find the major arc. So if I take this, the full one, minus the minor arc, I'll be left with the major arc. So this answer, just remember, is the green bit. So what I'm going to do now is I'm going to say that S of AB, now just remember this SAB is the major part, okay? And this is going to be equal to 2 pi r minus this 6, our minor bit. So that is the major, that is the minor bit. Okay, so all I'm going to do is just substitute my radius in, and we get 2 pi times by 3 minus 6, and we get 12,85 centimeters. And this is the major arc. Okay. All right, grade 11s, let's go into example 3. Okay, example 3 is saying the minute hand of a clock is 3.5 centimeters long. How far does the tip of the hand move during 20 minutes? So if I just look at a clock, now the minute hand can move 20 minutes wherever in the clock, but all I'm going to do is I'm just going to focus, say, from 12 o'clock until now. Just remember that over here, that would be, so we've got here 5, 10, 15, and then 20. So that's the movement that we're interested in from there to there. Okay. So over here, we know that's 90 minutes. Now what I need to do is I just need to work out how much each one of these 5-minute intervals is in terms of radians. So if that is 90 degrees from 12 until 15, That's 90 degrees. So we now know that if I divide this by 3, we're going to get 30 degrees for each little segment. But now remember, what we need to do is we need to convert the 30 degrees into radians, okay? So what I do there to convert into radians is just multiply by pi over 180. And if we do that, we get pi by 6 radians. So each one of these things is pi by 6 radians. Now, what we need to do is we need to add on that extra little bit there, okay? So this is 1, 2, 3, 4. So we got 4 times this to get the 120 degrees, because that would be 120 degrees. So if we multiply that by 4, we should get, so for 20-minute movement, we are going to get 4 times pi by 6. And that will give us 2 pi by 3. Okay, so now we know what this angle is here. It's 2 pi by 3. They also told us that the minute hand is 3,5 centimeters long. And we want to figure out how much it moves. So S is equal to R theta. Because remember, we want to figure out what this length is here. So we know what our radius is. Our radius is 3,5. And we are going to multiply that with our angle, which is 2 pi by 3. And you can put that on the calculator and you will get 7,33 centimeters. So that is how far the minute hand moves. Okay, example 4. It says here, a railroad curve is to be laid out in a circle. What radius should be used if the track is to change direction by 25 degrees in a distance of 36.6 meters? So I'm not interested in the full circle. All I'm interested in is, I know for every 25-degree movement, this must lay out a track of 36.6 meters. Okay, and if we carry on doing that, we will make a full circle. Okay, so what they need to know is what is the radius equal to, so that for every 25-degree movement we move 36.6 meters. Now, the first thing that I need to do is I need to convert the 25 degrees into radians. So 25 multiplied by pi over 180, and we get 5 pi by 36, okay, radians. So now we know what our angle is here. We know the arc length. We can work out the radius using this formula here. R is equal to S over theta. So we get 36.6 over 5 pi by 36. Put that on your calculator and you will get 83,881 meters. So the radius needs to be 83.881 meters long, okay, for that to happen. All right, grade 11s, let's have a look at example 5. Okay, so example 5 is saying the area of a circle is 480 centimeters squared. Find the angle in degrees at the center of the circle that is subtended by an arc of 3 centimeters. Okay, so if I had to draw this, we know that the area of the circle is 480 centimeters squared. We need to find the angle at the center, that is subtended by an arc of 3 centimeters. Okay, and we want to figure out what is this angle equal to. Okay, now in order to work out theta, if we go back to our formulas, theta is equal to S over R. So we know what our S is. They told us it's 3 centimeters. All we need to do is we need to figure out what our R is first. And I'm going to use this area bit to help us with that. So I know that area is equal to pi r squared. Okay, now that pi r squared is equal to 480. So pi r squared equals 480. Divide by pi and we get r squared is equal to 152,788, and it goes on and on. Just take the square root of that and we get that r is equal to 12,36. Okay, to 2 decimal places. Now I know what my r is. I can work out what theta is. So theta is equal to S over r. So our arc length is 3 centimeters over our radius we just worked out, which is 12,36. Plug that in the calculator and we will get that theta is equal to 0,247. Now just remember that this is in radians. The question was, find the angle in degrees. So in order to convert this into degrees, I must multiply by 180 over pi. And we will get that theta is equal to 13,906 degrees. Okay, grade 11s. Last example, example 6. Okay, so example 6 is saying an arc PQ so we have an arc PQ, which is that over there, of a circle center O and radius 6 centimeters is S centimeters long. Okay. Given that the length of the chord, so this is the chord between P and Q, it's this line over here, it's that straight line bit over there. Okay. Given that the length of the chord PQ is 6, calculate the value of S. Okay, so because this is a radius and this is also radius, this will also be 6 centimeters. So in order to work out what S is, we know that S is equal to r theta. I need to find out what my theta is equal to. We know what r is, it's 6. So if I have a look here, we've got this triangle over here, which is got the length 6 centimeters, and then another 6 centimeters. This is an equilateral triangle. So for all the interior angles of an equilateral triangle, it will be 60 degrees. Okay. Now, in order to convert 60 degrees into radians, we need to multiply that by pi over 180. And we get pi by 3 radians. So now I know what my theta is. It's pi by 3 radians. So now we can work out the arc length. So S is equal to r theta. Plug in my values. R is 6. And my angle is pi by 3. And we get S is equal to 6,28 centimeters. Okay, grade 11s, what I would like you to do for homework is you can do on page 89, you can do question 3, 4, 5, 6, 7 for me, please. Thank you.